This gold looks 24 karat. It isn't. This was cast without blast furnaces, and this tiny mistake on its surface fooled collectors for a century. Today, we unlock 3 tricks pre-Columbian goldsmiths used to make impossible jewelry without industrial smelters. Trick number 2 is why museum curators don't polish these pieces. Welcome to TimeVault Stories, evidence-based history that feels like time travel. Stay to the end to see how a gold-rich skin can make a coppery core look like pure treasure. You might have heard the myth. Ancient Americans ran huge gold smelters, but the fact is, most of the gold they used was native nuggets and flakes found in rivers, so smelting or wasn't the main game. The real puzzle isn't how they found it. It's how they reached gold melting temperatures, cast ultra-thin forms, and made their alloys look like pure gold. This wasn't about big industry. It was about brilliant heat control, clever alloys, and surface chemistry. So where and when did this all happen? Goldworking exploded along the Pacific Rim of South America and into what we call the intermediate area. In the Andes of Peru, we see hammered gold sheets as early as 1200 BCE, with later cultures like the moche, sican, and chimu scaling up workshops. In Colombia, masters from the quimbaya, muisca, and tairona peoples perfected cast alloys called tumbaga from around 500 BCE. Further north, in Costa Rica and Panama, dense casting traditions produced bold, animal-shaped designs. It wasn't until after 600 CE that these techniques traveled by sea up to Mesoamerica, a journey we can trace through shared styles and methods. Now for our first trick, heat hacks that beat 1000 degrees Celsius. Gold melts at 1064 degrees Celsius. Charcoal can get even hotter, but only if you force-feed it oxygen and trap the heat. They did this with small, enclosed charcoal hearths, often with lids. They pushed air into the fire using cane blowpipes with ceramic tips. Their clay crucibles were specially tempered to withstand the heat and were preheated before use. But here's a bonus trick. They often didn't even need to reach gold's full melting point. By alloying gold with copper and sometimes silver, they created tumbaga. This mixture melts at a much lower temperature, somewhere between 850 and 1000 degrees, perfect for a small workshop. This is also why archaeologists find so few large furnaces. The setups were portable and left very few traces behind. Heat gets you molten metal, but how did they cast such impossibly thin, detailed shapes so cleanly? And how did they make coppery alloys look like pure gold? That's where tricks 2 and 3 come in. The superstar technique is lost wax casting. First, you sculpt the entire piece in beeswax, every tiny figure, every hair-thin wire. You attach wax channels for pouring and for air to escape, then cover the whole thing in a very fine clay shell. When you heat it, the wax melts and flows out, leaving a perfect, negative cavity inside the hardened clay. Then comes the crucial moment. You have one chance to pour the molten metal in. After it cools, you break the mold, and the treasure is revealed. We have receipts from the past to prove it. Some artifacts still have the little pouring gates attached. Under a microscope, we see the crystal structures that only form in a cast metal. The muisca golden raft, with its multiple figures and tiny rails, was made in a single pour. The famous quimbaya paporos, hollow and perfectly uniform spheres, are another stunning example of this mastery. And now, for the twist that fooled museums for decades, many of these solid gold objects aren't pure gold at all. The surface is playing a chemical illusion. This brings us to trick number 3, depletion gilding. This is how artisans turned a gold-copper alloy into something that looked like pure, 24-karat gold. First, they heated the object in a fire. Copper on the surface oxidizes before the gold does. Then, they used acidic plant juices or other natural solutions to dissolve and wash away that copper oxide layer. They would rinse, repeat the process, and then burnish or polish the surface. This collapsed the microscopic pores, creating a hard, gleaming, and surprisingly thick skin of nearly pure gold. When labs analyze these pieces today, they find a surface that's over 95% gold, while the core is a much lower purity alloy. This enriched layer can be incredibly thin or built up over many cycles. And this is exactly why museum curators never polish pre-Columbian gold. Aggressive polishing could strip away this fragile, man-made surface, seeing a key part of its history. So, did they ever actually smelt gold from ore? Occasionally, but it wasn't the backbone of their craft. Native river gold dominated. The large-scale smelters we do find, like the wind-dated furnaces high in the Andes, were primarily for smelting copper and making bronze. The knowledge from that larger industry was then cleverly adapted for small-scale, precision goldworking. Once you know these tricks, you can start to recognize the makers by their signatures. In Colombia, you see exuberant, los wax casting and superb surface enrichment. Like the muisca raft, in the Andes, cultures like the moche and sican excelled at hammering large sheets of metal and assembling them, and in Central America, the diquis and cocle peoples were famous for their complex, multi-part cast figures with rich gold skins. So the enigma is solved. The secret of the ancient goldsmiths wasn't giant furnaces, it was precision chemistry and brilliant design. They used oxygen-rich heat in compact hearths, clever alloys that poured easily, and surface enrichment that made a little bit of gold go a very long way. This was a golden age you can still read today, atom by atom. Which culture's technology should TimeVault stories decode next? The muisca, the moche, or the diquis? Comment your pick below. If this changed how you see ancient gold, hit that like button, subscribe, and share it with a friend who loves uncovering ancient tech. Thanks for watching.